I'm going to go ahead and get started here because there's quite a few slides to go through. Apologize in advance. It's probably going to be easier just to take questions at the end, and we're going to try to get through everything here. I'm going to talk about why this is important, the kind of data people can get to. The last couple of slides, I got some countermeasures and some examples. I'll try to hit that and not run through them too quickly. Thank you all for coming. Thank you to Black Hat for having me here today. My name's Benninger. I'm a senior consultant at Foundstone. We do a lot of web application testing there. Before I joined Foundstone in my .com days, I was kind of actually developing a lot of web applications. I started off with Foundstone doing the same sort of thing. So my viewpoint kind of comes from that world. But now we kind of get the chance, or I get the chance to actually break some of these web applications. So this presentation today really came from a lot of our customers seeing their web applications and then looking across the internet and kind of in a more general scope and seeing that these vulnerabilities do exist out there on the net today as well. And the kind of data that we're actually kind of interested in and getting to is data like this. This is a screenshot from an early example of the tool that's been released. It's on your CDs today. I'm going to talk about it a little bit more as well. Basically what it allows you to do is go through the autocomplete cache of Firefox and rip out all that information into an XML format. And the thing we found when we ran this on different machines, on one box alone we found 26 copies of 2 different credit card numbers and 4 copies of a social security number. So throughout this presentation, I just kind of want to get installed that storing sensitive information in your browser cache or in your browser at all is not the place where you want this data. So we're going to look at some ways of actually getting to there. And first, this type of attack, it's maybe a little bit different than some people are used to. We're not actually going against the web server itself. We're not actually trying to get into the database, the main repository of all this information. We're not trying to break through a bunch of firewalls or different networks and so forth. This attack is going to be against the end users. So the people actually going to these sites, entering data, and then getting stored there in the browser cache. So there's definitely been a rise in these client-side attacks over the years. We've seen a number of vulnerabilities in Firefox and Internet Explorer, any of the popular browsers. And what's particularly interesting in looking at vulnerabilities and grabbing information out of the browser cache is that for a lot of this information, we're not going to need to escalate our privileges. It doesn't matter whether you're running as root or you're running as an unprivileged user, the browser is going to have permissions to write to its own temporary directory, to read the registry settings that it needs to read and write from, and that's really where we're going to be looking for and grabbing some of this data out of. So it's going to be sitting there at kind of this first line of defense where a lot of people are going to be using to actually browse the internet, and when it gets exploited, this data should be available to the attacker. Now the benefit for the attacker in these cases is that it's instant gratification. We hear a lot of times about malware and zombieware, and that's so 2 years ago. It's all about financial gain right now. You know, the quicker you can get somebody's credit card data, the quicker you can get somebody's credentials so you can actually log in and purchase things. So with this type of, with its typical sort of client-side attack, a lot of times we hear about installing a keylogger or installing spyware. And then the user is actually going to have to trust their system after it's been exploited. They're going to have to then go and visit their banking site. They're then going to have to go out and purchase something. They're going to have to type something into their browser. Or even with the ransomware, where it's encrypting and locking files on the system, you still have to wait for the user to pay up so that they can unlock this data. Well, instead, if we start looking at the browser cache, we might actually be able to save a lot of time and grab this data right away. So no longer waiting. It's the instant that we pop the browser, start going through its memory, start going through the systems, the places on the disk where it can store information, can come back right away. So when we're talking about browser caching, it's rather broad. I'm just going to hit 3 areas in this talk today. And it'd be wrong for me not to just talk about the basics. So this is really kind of old school caching things, the first couple of slides here. These are things that people have known about for a while. I'm sure we've all heard stories about the cheating spouse, getting caught by not clearing their browser cache and their history, and somebody comes along and they know where they've been and what they've seen. For something like malware, when it gets installed, looking at the browser history and the browser bookmarks, it's a marketing person's wet dream. I mean, all this data right there. You want to find out what bank you use, want to find out who your friends are on MySpace, want to find out what you're going to and what your interests are. Right there in your bookmarks and history, you'll probably be able to suck out a lot of data. And another thing that we've noticed that people should have been aware of by now is not using GET parameters, using POST instead. The GET parameters can get logged into your browser history as well. The little screenshot that I have down there is an application that we've seen out on the internet where you got the account number getting passed right there, has a get parameter. So that data is going to be stored in my browser cache as well now. So there's a lot of different tools and a lot of different ways you can kind of go through the disk cache for any web browser. Plenty of popular tools. Probably all aware that it can store HTML files, JPEG files, anything that kind of gets downloaded off the web page can be put to disk. Same with session cookies. So for an attacker that's kind of looking through this, that might be a lot of data. So kind of quickly putting together some greps, some searches through that directory where it's going to be stored to can actually save an attacker a lot of time. It turns out that a lot of instances, there's actually the same names being used for those form variables. So if we search through the hard drive cache looking for things like credit card number, CC_num, CC_num, things like that, we're going to get a lot of hits on the data that we're looking for. It's also just as easy to go ahead and search for any 16-digit string. Probably get a lot of false positives, but it's some good hits as well. You can also just kind of search for any maybe three-number digit, followed by a dash, followed by another 2 numbers, followed by a dash, and another 4 numbers, social security numbers. There's some regular patterns for things that we can search for through this directory. And we'll actually look at doing the same sort of thing when we start looking at the actual browser memory RAM as well. So that was to the disk, but what about actually gets stored in the browser's memory while we're surfing around? Now, at first, I was kind of skeptical about this as an actual viable attack vector, but then I started thinking about my own sort of surfing patterns, and I don't know how many of you guys have been turned on to tab browsing yet. It's already in Firefox, it's in the next version of IE, and it's great. I am a tab browsing whore. If I don't have 15 tabs open, I'm not surfing the internet. You know, so it's just something that you really get used to, you really get into. So it's not going to be uncommon for me to maybe have my bank open in one tab. Maybe I'm going to be searching for information on a product I'm looking to buy in another tab. Maybe that tab after that, I'm actually looking on eBay or a site, maybe purchasing something in one of those, and then having another tab open where I'm casually surfing the internet. Well, I would like to think that maybe if I closed one of those tabs or actually logged out of my banking application, that data now isn't going to be available to an attacker if my browser got popped. Well, unfortunately, there's actually ways where that data can still stay in memory on the browser. And it's kind of easier to see with a little example. So the next couple of slides talk about that. In this example here over on the left, it's just kind of your typical web page bank login. Enter your username, enter your password. All that goes through successfully. You get taken to your My Account page. Now, what's going on actually behind the screen there is you got a little HTTP request going back and forth. You see in the top section there, we're actually making the request. And then we're posting some parameters in there. We're posting our username. We're posting the password. And the server responds here with just a 200 OK message. And after that, it's going to be followed by the data. So for all you picture people, this kind of looks like this. Got your login page, send it to the server, which it looks exactly like the server in my room. And then it gets passed back, and you get the My Account page. So in your browser, what does this look like? Well, you got these little back and forth buttons that I'm sure you're all used to. Now, that's going to be very handy if you need to go back, reload a page, need to go forward and go to something else. So the browser is actually remembering where it's gone so that it can take you back there if you need to. So for the login page, you either just typed it in yourself, maybe you actually had it as a bookmark, sucked it down, and it went there. So all it needs to remember to get back there is that URL itself. Well, to get to the My Account page, what'd you do? You actually had to pass it a bunch of variables, a bunch of parameters, and then, along with the URL, it gave you that page. So in the memory itself, if you need to go back and reload that page, it needs that URL and it needs that data that you posted to it. So it's going to remember that for you. So if we actually look at that browser memory, we're going to be able to go through doing the same sorts of search techniques I mentioned earlier, looking for some common form names, CC_num, password, username, things like that. And actually be able to search through and find the spot in memory where those credentials are. And the nice thing about this as well is that you probably notice a few lines right after that, you see the URL that it got posted to. So right off the bat, here I have all the information the attacker will need to post, log into the page, as well as the URL for the site. So in this screenshot here, I used a tool called WinHex from Xways. It's really easy to use and view the memory of any process. Metasploit has a shell as well that allows you to look at the memory of any process. So this is definitely available to an attacker if he exploits the machine in the browser. And again, this is the browser's own memory. So we're not going to really looking at raising our user level to view some other process that we don't have permission to. This is the process that we're already running in. And it's not just credentials, but basically any form that gets submitted to a web server that we get a 200 OK response from. So again, this could very easily be credit card information when we post a form to another site. So how about autocomplete data? We've probably all been to our favorite search engines, started typing, seen some of the past searches that we've entered before. So what we're going to be looking at here is what's actually stored within the browser's autocomplete cache. So this isn't something like Google suggests where it's coming from the server side. This is going to be locally within your browser. So don't want to mention password autocomplete. That's pretty old school. People are aware of that. Users are pretty good at knowing when the browser is storing this information. You get some nice pop-ups. Firefox has a way for you to triple DES encrypt your passwords. So that's a different type of autocomplete. People should be aware of it. There's a lot of reference that you can find about it. But what's a little bit more interesting is just the regular form autocomplete. And how this is different is just that any input field that's of type text, if you have autocomplete enabled, it can store the value that you entered based on the name of that input field. And it doesn't matter what domain you're on, it's going to store it in the same sort of repository based off of the name. So with password autocomplete, your Amazon password doesn't get tried over on eBay. Your browser's smart enough to recognize the difference there. But with form autocomplete, what it enables you to do is if you enter your address on, say, something like a site booking a hotel reservation, when you go over and you book your travel, your flight information, and if they have the address field named the same thing, you entered it on one site, it can save it and re-enter it for you on the next site. So that's usually a nice feature for people, and they'll tend to have that enabled because it comes in pretty handy instead of having to re-enter your email address or your address all the time. And maybe for things like that, it's okay, and we're not so concerned about. Where it gets more interesting, though, is form fields that are credit card numbers, form fields that are social security numbers, account numbers, mother's maiden names, configuration passwords. All that type of information, it's just an input text box as well. There's nothing preventing your autocomplete cache from caching that information as well. So where does that data actually go to? In Internet Explorer, it actually puts it to the registry under Protected Storage System Provider Key. So this has been something that's been around for a while. If anybody's ever used Kane, Kane can go through and actually pull out the information from here. There's a program called Protected Storage Passview. Does a really good job of going through here and listing out all this information if it's been entered with IE. Firefox, it works a little bit differently, that it actually stores it to a file within your profile. And this is an example of where it is on a Windows system. It's in a similar location on a Linux system or on a Mac OS system. Now, if we take a look at that file, it looks something like this. It's a file format called MORC, perhaps one of the ugliest file formats you'll ever come across. So taking a look at that and trying to get anything valuable out of there, it's a little difficult. So what we've done is we come up and written a tool. It's a Python script. It's on your CDs. It's also available off of the Foundstone website now. We compiled it to an exe as well for Windows users. And it makes it really easy. Just if you run it without any commands, it'll look at the default profile of the user that you're running under. It'll go through and find out where the formhistory.dat or formhistory.sqlite file is on your system. Go through that MORC file and parse it all out as XML to your screen. So you get a nice little dump like this, and it makes it pretty easy to go through and actually see what type of information that you have stored in your autocomplete. So this works on the Firefox, the 1.0s. It also works on the 2.0, the alpha and beta. They kind of changed things a little bit with 2.0 for a little while. I think they've gone back to using MORC for now, but it'll handle either of those. And if you happen to grab a form, the file itself, formhistory.dat, off of another system, you can pass it to this executable as well, and it'll rip through that and dump it as XML. So this is the slide where I'm kind of urging people to go out and get yourselves tested and tell your friends to get themselves tested. It's a really good chance that you are going to have some of this information within your autocomplete cache. If you have autocomplete enabled and you booked your own reservations to come here to Black Hat, good chance that you're probably going to have some sensitive data in there. Airline reservations, hotel reservation sites, Pretty notorious for this. We found it as well as some major online stores. If anybody's in a black suit and black sunglasses in the back of the room, a lot of government sites require Social Security numbers on all of their forms. Any of the ones I came across didn't really seem to be turning off autocomplete. Good chance that data could be in there as well. So this is the countermeasures. This is a little moment to talk to other developers and say that we gotta get things together. We gotta fix this problem. End users, they can fix the symptoms, but really the disease is within the web applications themselves. And there's some pretty easy ways for developers to go about and fix these issues so that the end users who's not aware of this data getting stored, because a lot of times it's happening behind the scenes, without a lot of knowledge, you just turn on autocomplete and that data doesn't get asked whether it's going to be into there or not. A lot of people that aren't, cheating spouses are probably not going through and always clearing out their browser history every time. So really the web applications themselves can be taking a lot of steps to prevent this information from getting stored there in the first place. So when we talked about the disk cache, HTTP 1.1, it's been around for a while. It's not just for your labs anymore. It's got cache control headers. So let's go ahead and set those as actual HTTP response headers. Don't cheese out and go for the meta tags because those won't always be read, but they can actually be a response header there. Cache control, no store. Prevent any of the data from being written to disk. If you happen to find somebody talking the older HTTP 1.0 to you, Pragmata no cache, most browsers are going to understand that. Set an expiry date for something in the past. Help prevent that data from actually being stored to disk. And of course, if there's no need to have every page display my account number to me when I know it, maybe just have a little form on there that I can click and actually then view my account number or anything sensitive like that. Require me to put in my password again, just in case anybody stolen my cookie. And when you ask me for my password or any other sorts of sensitive information, go ahead and stick a redirect in there. They're fun, they're exciting. There's lots of different flavors of them. A 301, a 302, a 303, make it exciting. Just redirect my browser and put something in between before that 200 OK message, and the browser's not going to remember the data that you posted to the form. And for the autocomplete, there's a couple different options as well. We know developers, they love more attribute tags, so hey, we got one more for you. Autocomplete equals off. You stick that in the form tag, and that's going to disable autocomplete for the complete form. So it no longer will password autocomplete work for you. It'll be disabled. So if you're doing a banking application or something with other sensitive information where probably even your mom and pop shouldn't be storing and remembering their password, you can disable that for it. In other cases where it's all right for getting the name and the address and you just want to make sure that the credit card information doesn't end up in somebody's autocomplete, you can go ahead and just add it to that tag and prevent it from just coming from certain inputs. So it looks like I have a few minutes left if anybody has any questions. Thanks again for coming and listening. And like I said, the autocomplete dump tool, it's on the CDs. It's also on the Foundstone website. Okay. Thanks.